Hey guys, today we're getting into our very first look into proofs, and we are going to start with some algebraic proofs. So first we need to talk about a few different properties. All of these are properties of equality, and that will become more important when we do proofs of geometry, but with these algebraic proofs are all going to be properties of equality. So if we have A, B, and C being any real numbers, if we know that A equals B, then by the addition property, we know we can add something else to it, that letter C. And anything we do on the left side, think back to algebra, we do on the right side. So A plus C would equal B plus C. Similarly, with the subtraction property, if A equals B, then we know that A minus C would equal B minus C. We're taking away the same thing on both sides. Multiplication property works very much that same way. We multiply the same thing on both sides. So A times C equals B times C. And again, the division property. A divided by C equals B divided by C. The last one is different though. The substitution property says that if A equals B, then A can be substituted for B in any equation or expression. It doesn't quite fit on the line there. Okay, so here's our first proof, and I want you to notice a couple things. It gives you a problem to solve, and you'll see two kind of columns here. You see equation and you see reason. And everything I write down, you need to write down as well. So the first thing we're going to do is write down the problem exactly as you see it. So I'm going to write down, I'm going to put a number 1 by it. 2x plus 3 equals 9 minus x. We have to say the reason that we wrote that down. And so since this was the equation that we were given, we're just going to write given. Now, I'm going to do my work in a different color just so you can see the difference on what's happening. You need to show this work. So there are a couple different things that you could do first. I'm going to combine my x's. So since I have a minus x, I'm going to add x to both sides. So then my line 2, my new equation, would look like 3x plus 3 equals 9. Okay, again, we have to say a reason. So of those properties we dealt with before, notice we added the same thing to each side. So that's the addition property of equality, and I'm okay if you write POE, or you could write prop of, and put an equal sign. Either one of those is okay. You don't need to write both. Okay, then we need to keep working through this problem to solve for x. So I'm going to combine my numbers. So if I have a plus 3, I'm going to subtract 3 from both sides. So my next line would look like 3x equals 6. So then my reason for doing that was subtraction, and I'm going to shorten subtraction to SUBT. Make sure you don't get that confused with substitution. I shorten that to SUB. So SUBT, property of equality. You can always write all of this out if you prefer. Okay, then the last step to get x by itself, we're going to divide by 3. So if I divide by 3, then I end up with x equals 2. And my reason is how I got from step 3 to step 4. So dividing by 3, that would be the division property of equality. So that is an algebraic proof. We write our equation, we put our reasons right next to it. Let's try another one of these. One more property I'm going to give you though. Notice this is not a property of equality because we're not crossing an equal sign. So the distributive property should be one you're familiar with from algebra. A times the quantity of B plus C. We can distribute that A. And so we have A times B. And then A times C. And we put that plus sign in between where A, B, and C are all real numbers. All right, let's try example 2. So, step 1, I'm going to write my equation. -4, quantity 6x plus 2 equals 64. My reason is that this is given. Okay, a couple different ways you can solve this, but since we just learned a new property, I'm going to use that property here. So I'm going to go ahead and distribute this -4. My work and my new equation are going to look the same. So I have -24x plus -8 or -8 equals 64. So my reason then would be the distributive property. Notice I didn't put of equality there. Okay. Then to get rid of that plus a -8 or -8, I'm going to add 8 to both sides. So my new equation looks like -24x equals 72. How did I get there? I added, so addition, property of equality. All right. Next step is divide by -24. So 72 divided by -24, we get x equals -3. How did I get there? We divided. So division, property of equality. Okay, a few more properties of equality, and so we're going to talk about these properties in terms of real numbers, in terms of segment length, and in terms of angle measure. So the reflexive property is going to seem a little silly right now, but we'll use it quite a bit. So the reflexive property just says that something is equal to itself. So for a real number A equals A. For a segment, AB, the length of AB is equal to itself, AB. For any angle A, the measure of angle A is equal to the measure of angle A. So that's the reflexive property. It's equal to itself. Another one we have is the symmetric property, and this one tells us that if you have two things equal to each other, that order isn't important. So if we know for real numbers that A equals B, we could say that B equals A by the symmetric property. If we know that the segment AB equals the length of the segment CD, then we can say that the length of CD equals the length of AB. Same thing here with angle measure. If we know the measure of angle A equals the measure of angle B, we can reverse that and say the measure of angle B equals the measure of angle A. That is the symmetric property where they switch places. Okay, then the last property is the transitive property. So the transitive property deals with three different values here. So real numbers A, B, and C. And this says if A equals B and B equals C, we can go straight from beginning to end and just knock out that middle piece that overlaps. So we know then that A would equal C. Again, here the length of AB equals the length of CD. The length of CD equals the length of EF. So we can say then the length of AB equals the length of EF. And then for any angle A, B, and C, the measure of angle A equals the measure of angle B. The measure of angle B equals the measure of angle C. Again, go straight from beginning to end. The measure of angle A is equal to the measure of angle C. All right, that's all I got for you today. So I will see you in class. As always, come in and see me if you have any questions.